Okay, so most of you are here, so let's start. So before starting a new topic, I would like to discuss your mid-sem paper. Okay? So there were 15 questions, and so this was created in collaboration with the other instructor, Supanta Pandit. So I'll start with the problems which I had created. Let me. Yeah, let's start with this problem, right? Then we'll come back to the first 8 questions. Okay. So this was, you had to appear for a set of quizzes whose start and finish times are given. Each quiz carries either 5 or 10 marks. And you can appear for only one quiz at an instant of time. Which of the following greedy strategies will you apply to maximize the total number of marks you are appearing for? So this was, you can think of it as a weighted interval scheduling problems. You can only appear for one quiz, but each of these quiz carries some weight, 5 or 10 marks, and you want to maximize the total number of marks. Okay, so I guess it is easy to see that none of these things works. What about this guy, earliest start time, right? So you can give many counter examples to this. Okay? Let's say that you have some quiz from time 1 to 3 that carries 5 marks. Okay? And another quiz is from 2 to 4 that carries 10 marks. Okay? So the weighted interval scheduling problem, it works very differently from the unweighted case. Okay? So you have a quiz from 1 to 3 that carries 5 marks, 2 to 4 that carries 10 marks. So earliest start time is definitely not going to work, because then you'll attempt this 5-mark quiz when actually you should be attempting 10-mark quiz. Okay? Same thing for earliest finish time. Okay? Again, you'll attempt the quiz of 5 marks for 1, 2, 3. Yeah? And same thing for this 5-mark quiz with earliest finish time. So neither of these strategies works, and so the answer is none of the above. And I guess many of you got this. Are there any questions regarding this question? Okay, so standard greedy algorithm question. What's the next one? Yeah, this was another easy one. Suppose you are given an array of n distinct elements and we want to find n by 2 elements in the array whose median is also the median of A. Okay. Which of the following is true about this problem? So you want an algorithm, you are given an array of n distinct elements and you want to find n by 2 elements in the array whose median is also the median of A. So yeah, tell me how you solve this problem. Sort the array. Actually, you can do better. Okay. So, in fact, you can do it in linear time. So you
Yes,
don't
sir.
necessarily. Yeah. So.
Sir, we can find the mid element from this n array.
Yeah. An array.
And then we will just check that how many elements are required for us, because we are supposed to find n by 2 elements in the array. So
Yeah.
we have just fixed element, that middle one. Just
Yeah.
now we have to find just n by 2 minus 1 divided by 2 from left and right
Yeah.
side both.
Yeah. Sure. Yeah.
So
So the answer is C. This problem is in linear time because we discussed a linear time median finding algorithm in class, and it uses divide and conquer. So some of you have tried to sort this array and then find these n by 2 elements, but you don't need to do that. So some of you have ticked option A. That is not required. N log n is not necessary. You can solve it in linear time using our median finding algorithm. Yeah.
sir, but in this question we can have more than one answer, right?
How?
Uh,
So which one else do you suggest?
if no, but I'm saying if we have given this n by 2, but instead of that we can have like suppose we have totally 10 elements, and
Okay.
suppose we have to find only 3 elements or 4 elements among
Okay.
them, in which the middle one is the same for both of them. So we
Okay.
can have more than one answer, right? Because the middle one will be there, but
Yeah. More than one.
effectively in left side and right side we can have two means more than one solutions.
Yeah. Sure.
But in this case, it will not work because already we have given n by 2 elements. So we have
Yeah.
to just check
Yeah.
all our.
Yeah. Yeah. You can give more than one output to this. That's completely fine. But just what procedure you are using, that is more important.
Okay. I'm sorry, sir. In this case also, that will work, means we can have more than one answer.
Yeah.
Okay.
Okay. This was another easy one. So we had the all pair shortest path problem. So you had weights assigned to the vertices as well as the edges, and the weight of a path is the sum of the weights on the edges and the vertices on the path. So in class we had discussed Dijkstra's algorithm, and so Dijkstra's algorithm just assumes that there are only weights on the edges. There's a slight variation. You had weights on the vertices as well. Okay. So so what difference does it make? Well, so consider any path. Okay. Apart from the starting vertex and end vertex, every other vertex appears twice on this path, right? Because it is either the uh, starting endpoint of an edge or it is the ending endpoint of an edge. Okay. And you just had to use this, and therefore you will assign every edge a weight of half of WU plus WV, because both these vertices are appearing here, plus the weight of that edge. Okay. So whenever you apply the all pair shortest path algorithm, what it will do is it will just add up all of these weights. Okay. So all vertices except the starting vertex and the end vertex, they will totally get WU plus WV plus this weight of this edge. Okay. So C option works here. And yeah, that's the correct answer. Again, many of you have got the answer to this.
Sir, why do we half the weight?
Because any algorithm which you are solving, so let's look at some path. Okay, let's say it's going from U1 to U2, U2 to U3, and so on up to UK. Okay, so we have these edges. So edges is clear. It should be W of UV because then we will sum up over all of those. Okay. What about the vertices? So what is happening here? We'll add half of W1 plus WU2 plus half of WU2 plus WU3 plus half of WU3 plus WU4. So apart from the starting vertex and the end vertex, every vertex is appearing twice. Okay. And therefore you need to put this half so that that particular vertex weight you will get on this shortest path. Okay. So finally, what we will get is half of the weight of the starting vertex plus half of the weight of the final vertex plus the weight of the intermediate vertices on that. Plus not half, only just the sum of the weights of the intermediate vertices on that path. Okay. And once you apply Dijkstra here, you will get the weight of the shortest path, where it is the sum of the weight of the vertices as well as the edges minus half of the initial vertex weight and minus half of the ending vertex. Okay. So that is why that's the logic behind this half here. Okay. Some of you said that Dijkstra is useless for solving this problem. That's not correct, because using a slight modification, slightly different weights, you can actually solve this problem using Dijkstra. Okay. Some of you answered this particular option, but even if you use this weight, you will have to put a half here to find the actual weight. Okay. So option C is correct here.
Sir, but it will not create any difference in the final answer of the when we apply the algorithm.
What will not create uh, difference?
Sir,
Yeah, it will not create any difference. Yeah, that is
sir,
true.
sir, then the B answer should be also be correct, right, sir?
So what's the logic behind B here, right? So you apply this weights W plus WV plus W of UV. Okay. Yeah. So in a sense, you are correct. So what are you going to do here? Every vertex will appear twice here.
But we are making just comparisons in the algorithm, right, sir?
Yeah. Finally, you are going to apply a half here, right?
Can you please repeat, sir?
Uh, so, uh, so how is this algorithm going to work? So you'll assign a weight of WU plus WV plus WUV. Okay. So let's
Yes, sir.
forget about the edges and every other vertex. So what you get effectively is 2 times the weight of this, but then you need a 2 times here as well, WUV. Okay. And therefore, so it's at that way you will get 2 times the weight of the shortest path and then half of here. So if you are given this answer, this doesn't work exactly in the format that we are giving here, right? So I haven't given credit for this answer or this answer, 3/4 of W plus WV plus W. So maybe if I had written 2 times WUV, this answer would have gotten credit, but otherwise it's not. This is the best way to do it. Half of W plus WV plus W of UV.
Okay, sir.
Okay. Okay, this is another interesting question. We need to hire programmers to solve a set of n related programming questions. And there are m different programmers available for hire to know exactly two questions. Given the solution to one, he can figure out the solution to another. Okay. So he needs a code which describes the solution to one, and then he can find out the solution to the other. Okay. And they can work together to discover solution to new pairs. So if one guy knows the solution to A, he can figure out the solution to problem B, and other guy, if given the solution to problem B, he can figure out the solution to problem C. Then together they can work to find out if you are given solution to problem A, you can also find solution to problem C. Okay. And so this way they can work together to discover solution to new pairs, and each programmer has a non-negative hiring cost. And you need to find a minimum cost set of programmers so that for every pair of problems, given the solution to one problem, you can find the solution to the other problem. Okay. So some of you have selected all pair shortest path. Actually, I do not know how to solve this using all pair shortest path. So if you have any idea regarding this, please feel free to share with me. So solution I know is of this minimum spanning tree. Okay. Because you can think of it as a graph, because each guy only knows two questions, and if he's given the solution to one, he can solve the other problem. And this working together in pairs is basically the transitive property of this. If you are given the solution from A to B and B to C, you can find out A to C. Okay. And we want every pair of problems. You are given the solution to one problem, you can find solution to the other problem. So what we are looking here is we want some minimum cost set of edges, because every programmer is effectively an edge here. He knows exactly two questions such that given the solution to one, can figure out the solution to the other problem. Okay. And we want a minimum cost set of edges so that the final graph is connected. That's what I mean by given the solution to one problem, you can find the solution to the other problem. And that's exactly the definition of minimum spanning tree. Okay. So any questions regarding this problem? So many of you got this, but some of you have gone for all pair shortest path, which I don't see how to solve it using all pair shortest. Okay. The next problem, many of you gave wrong answers. So this was an interesting one. So you are given a set of endpoints, x, y coordinates are given, and we need to divide them into two groups such that the minimum distance between any pair of points is maximized. And it should belong to different groups. And the algorithm to which problem will be useful for solving this problem. Okay. Actually, it was not all that difficult, just looked difficult. Okay. Many of you have set closest pair, but I don't see how you can closest pair here. So the usual way to solve it, solve any problem is to use a specific model for this problem. Here, the graph theoretic way does work. And so what's the idea here is that each point you consider as a vertex on the graph. Okay. And what you'll do is you'll compute the distance between each of these points, okay, between 2 points. And that distance you can compute easily. Okay, it's a constant time operation, and that will be the weight of your edges. Okay. And what we want is minimum distance between any pair of points belonging to different groups is maximized. Okay. So what we want is we want to partition the vertices into two sets such that the minimum distance between points belonging to different groups. Okay. So it's the smallest edge weight which is going between these two different groups. Okay. So you can think of it as a cut. Okay. Graph cut such that the minimum weightage is crossing the cut. And that we want it to be maximized. Okay. So in fact, at this point, the minimum spanning tree should have struck you. Is because every time we compute a minimum spanning tree according to Prim's algorithm, we always pick the minimum edge weight crossing the cut. Okay. And so the first natural idea is we compute the minimum spanning tree and we want this minimum distance to be maximized. Okay. So what we do is we delete the maximum weightage from the spanning tree. And that's the way we can maximize the minimum distance between any pair of points. Okay. So it's another simple application of minimum spanning tree. Okay. So the answer is minimum spanning tree here. Some of you have take closest pair, but when you have this maximizing the minimum distance, it's not completely yes. Because this will be an exponential time algorithm, I guess. Because first you need to find out these two different groups, right? There are many such ways to divide them. They are almost 2 raised to n by 2. So closest pair is not a good option. Can do it in polynomial time using minimum spanning tree. Okay. So this was next question is a disk consisting of a circle plus its interior and is represented by center point and radius. And two disks intersect if they have point in common. Okay. And we want to decide if any of two of these disks intersect, find the time complexity of the best algorithm for this problem. Okay, anybody got this? Any ideas?
Sir, we can compare their centers and radius to find if they will intersect, whether they will intersect or not.
Okay. Yeah, so we'll find the distance between the two centers and sum up their radius. If the distance between the two centers is larger than the sum of the two radius, that means they are not going to intersect. Okay, so this works for two disks. But there is a better approach for n disks. Okay? You can use some kind of divide and conquer. Okay. So what we'll do is we'll find some vertical line such that half of the disks are to the left side of that line and half of the disks are to the right side of that line. Okay. So we'll find the leftmost point of and the rightmost point of these circles. Okay. That you can easily find using the center point and the radius. Okay. This you do for every disk. Okay. And then we find the median of all of these points. That you can do using divide and conquer, and we'll just take linear time. And it's the exact same idea as we used for the closest pair. Okay. And whenever you have these things where half of the circle is on the left side, half of the circle is on right side, then you look at the y coordinate. And based on that, decide if any of two of those intersect. Okay. So what's your recurrence here? So let T of n be the time taken to decide if you are given n disks. So you divide into two halves, 2Tn by 2 plus theta of n. That's when you want to decide whether if half of the disk is on the left side, half of the disk is on the right side, how are you going to decide that? Okay. So theta n log n, many of you got this simple divide and conquer approach. Okay, this problem, I saw that many of you have just left it. Maybe found it a very difficult problem also. Some have given wrong answers. Theta of n log k, that is not. At least I don't see any n log k algorithm for this problem. Yeah, so you're given a set of endpoints in the two-dimensional plane. Assume that there is some k such that the points can be divided into k clusters. Each cluster has radius r. So you have these clusters or circles. Each cluster has radius r. Center of each cluster has distance at least 5r. And each cluster contains at least epsilon. So you need to use this information to construct an algorithm computing the number of clusters. So what is the time complexity of your proposed algorithm? Yeah, any ideas for this one? So it just looked difficult, but actually the final thing is very easy. Okay. And what the idea is that you pick any point, okay, and look at all points which are at a distance of 2r. Okay? Because inside this circle, the maximum distance can be 2r. Okay. So that's how you use the first property. Look at all points which are at distance 2r, and all those you put in one cluster. Okay. Then pick some other point. Again, pick all points which are at distance 2r, put it in the second. And the important thing to note here is that the point which belongs to some other cluster is not going to fall in some other cluster in this approach. Okay. Let's say you have a point, you picked all points at distance 2r, then a point of other cluster is not going to come in because the center of this cluster is of distance at least 5r. Okay. And yeah, that's it. That's the algorithm. Pick any point, pick all points at distance 2r, and then pick some other point, pick all points at distance 2r until you finish off all the points, and this way you get the K clusters. Okay. So every step takes theta of n time, right? Because potentially there could be n many points which are at distance 2r from your point. So each of these steps take theta n time, and there are K clusters. So you have to repeat it K many times. Okay. So simple greedy approach, theta and K.
Sir, here
Okay.
I'm having a question with regard to the question. Sir, here what
Yeah.
what are the clusters we need to find over here?
So cluster is essentially a circle, right? You are given its radius and you are given the center, which has distance at least 5r from the center of any other cluster. Okay. And
Sir, but it is not told that we need to find the clusters with the upper
no,
radius.
you
This one.
don't need to. Yeah, you just need to find the division of the points into this cluster.
Okay, sir, means we need to find.
Okay, let's see. Yeah. Okay, let's see what to do about this problem. Okay. So actually, it's stated very clearly, construct an algorithm for computing the number of clusters. Okay. And yeah. So what's the time complexity of your proposed algorithm?
Sir, I was just having the doubt that whether we need to find a cluster that satisfies the state property in the question, or we need to divide it into clusters.
No, you just needed to find the number of clusters.
Okay, sir.
Okay, so that's what this line was there for. You need to use this information to construct an algorithm for computing the number of clusters. Okay. Anyways, you can always ask during the exam if you don't understand some problem. Okay, so this was these 7 problems. So now I'll move on to the other problems which the other instructor have created. So some of the answer keys I don't quite understand, but let's see what happens. Okay. So yeah, this one. Recall the following functions, rank the following functions by their order of. So I don't know why all of you have got this answer wrong. I mean, many of you have got the answer wrong, because this was one of the easier ones. So we want to find the ordering of these functions which satisfies f1 equal to big O of f2, f2 equal to big O of f3, f3 equal to big O of f4. Okay. So all these are in fact super polynomial stuff. Okay. None of these are polynomials. 4 raised to log n, that is, no, this one is linear time, right? So it's very clear that log n cube is the first one. Then comes this 4 raised to log n. Whenever you have these powers, the best thing is to write it as 2 raised to power of something. Okay. Or here it is 1.3 raised to n. Okay. And just compare their exponents. Okay. Here the exponent is log n, here it is n, and here it is log n into log n. Okay. So log n is going to come first. 4 is, sorry. Your question? Okay. So here you have log n. Here you have n, and here you have log n times log n. So log n cube comes first, 4 raised to log n, then n raised to log n, and then 1.3 raised to. Okay. So this was a fairly straightforward one. Yeah. So this one, I think the answer key given was wrong. So don't worry. You'll get the marks if you have ticked big O of n squared. Okay. It's, I think, 69. So what's the recurrence here? T of n equal to 69 T of n by 23. Okay. In each problem, you are dividing the k into 69 subproblems. Each subproblem is of size k by 23. And in that step, it also incurs a cost of theta as well. Okay. So a simple application of Master's theorem, and what you need to compare is log 69 to the base 23. That is less than 2. So I think you'll get the answer if, marks if you get big O of n square. Somehow big O of n cube was given for this problem. That's not correct, big O of n cube. But I think most of you have given big O of n square. So okay. So next question is simple breadth-first search. Given these 3 odd rings, and want to find the order of the vertices that are inserted in this cube. Okay. So the first one doesn't work because we put S into the cube, then we put A and D, that's fine. But then the neighbors of A needed to be put into the cube. In this case, it is C, which is not following the right order. Okay. Then the next one, second one is correct, because first you are putting D into the cube. Then all its neighbors. Okay. And the third one is basically CATBES. Okay. So that also doesn't work out because you're putting A, D, then suddenly you go to B.
Hello, sir.
Yeah.
Second one is not correct, right? B, then C, E, and
so why?
G also should be. B is also a neighbor of
Oh,
D,
yeah.
right?
Yeah. That is true.
So answer should be none of the above, right?
Yeah, I think so. Yeah. So as I said, they are not questions created by me. So let me confirm from the instructor. He had something else in mind. Okay. Yeah. So I think none of the above will get credit for this
But
one.
sir, here in Q, we don't think like D, then it's two child C and E, then the child of C, then the child of P are written in Q.
No, so the issue is that B is also a neighbor of D. Okay.
Yes.
So you put C, E, and then B. And then the child of A, C, and then the child of E. And then the child of B. So why didn't B come here earlier? Yeah, that's a good point. Okay, let's see what to do about this. So this one again, I think the answer key is wrong, but let me see. What happens. I think they should have different minimum spanning trees. So you are given these two graphs, edge weights are different. The two graphs are just the same in terms of vertices and edges. So if an edge has a weight W in G, the same edge has a weight W squared in G. And because these weights are positive, negative, so it might be that the negative weight is coming earlier in the graph G. But in G prime, we are considering the squares. So it could be possible that this negative weight is coming later in this graph G. Okay. So I think both G and G prime should have different minimum spanning trees. But let me confirm from the other instructor.
Yes, sir. Actually, B should be correct because
Yeah,
in G, if there is negative weight, then we should always
yeah,
proceed with that of negative one. And in G
yeah,
dash, all
yeah,
are positive. So
yeah,
path should be different both sides.
yeah, sure. Yeah, I also think they should have different minimum spanning trees.
Sir,
Uh,
sir, if
yeah,
we have negative edge weights, then
yeah,
minimum spanning tree will be different in both. But we only have
yeah,
positive edge weights, then minimum spanning tree will be same
yeah,
in both G and G dash.
same, yeah,
So
yeah,
this
yeah,
is
yeah,
in this case dependent. Sometimes have
yeah,
same minimum same spanning tree, and sometimes it have different span.
yeah, that is also a good point. So then, yeah, but it was clearly mentioned here. Suppose the weights in G are both positive and negative. So you don't need to consider only the positive case.
Okay, sir. Okay.
Yeah. Okay, this is a simple application of Prim's algorithm. Okay. So it depends on where you start from. In this case, we are looking at, let's say, C. Okay. So you consider the minimum weightage, CD. Okay. So we have C and D in one group and all the other are in the other groups. And then you'll go to DA, right? Because the 7 weightage is the least weightage here. So CD, DA, then we have AG, because 10 is the minimum weightage here now. And then we have AB, because 14 is the minimum weightage. Okay. And then finally only E remains. Okay. And there is only one way to cover this, C comma E. Even though it is a very high weightage, we will have to take that. Okay, so option A is correct here. Most of you got it. It's just following the simple Prim's algorithm. So there is a question. Yeah, EFS question. Okay. Okay, next one is also an easy one. You are given these two statements. 2 raised to n plus 1 is big O of 2 raised to n, and 2 raised to 2n is big O of 2 raised to n. So obviously the second one is wrong. Okay. First one is just 2 times 2 raised to n. So 1 is true, but 2 is not. Okay. Most of you got this answer correct. and yeah, this one. So we need to find, we are given a sorted array. It contains positive integer values, including 0. And you need to find the smallest positive integer that does not belong. Okay. And so, yeah, how are you going to solve this? Any ideas?
We can just traverse the array and find the first integer that is not appearing.
Yeah, that is a linear time, but you can do better.
Sir, we can do it with binary search.
Yeah, binary search. That's correct. So how are we going to do binary search? So we need to divide the array into two parts, the first half and the second half, and look at the starting value and the ending value. Okay, and the size of this half. Okay, if the so we are starting with 0, or let's say any value. So you need to consider the starting value and look at the ending value. If that compute the difference. Okay, if the difference plus 1 is equal to the size of this half, then you are sure that none of these elements have been missed here. And if the difference is larger, then you only need to look in this particular half. Okay. And yeah, that's the way you solve this problem. So every time you are reducing the space by half the number of elements, therefore you get a log n time algorithm. Okay. So you should be able to use these things now instead of just iterative solutions. So log n is the best time complexity for this problem. Yeah, this one many of you have got wrong. I don't know why. So you want to find the k integers from A that are closest to T. Okay. And A contains these values and k equal to 3. Let's say T equal to 14. So the closest to 14 is 8, 12, 15. Okay. So the problem is easy. In fact, you even had a lab assignment on this where k equal to 1. So this should, I was expecting everybody to get it, but somehow people didn't get it. Yeah, so any ideas for solving this? K closest integers to T. Okay, so we have an answer. Find the first element from binary search. Yeah, that's exactly what we did in the lab assignment. Found the first integer which is closest to T. And then it's you just set the point. So what are the candidates now? Let's say you found this element. Okay. So you look at the k minus 1 elements to the left and k minus 1 to the right. Okay. And of these, you need to pick some. So there are totally 2k minus 2 elements, and you need to pick some k minus 1 elements of these. Okay. So you pick the leftmost among these 2k minus 2 elements, pick the rightmost among these 2k minus 2 elements, and look which one is closer to t. Okay. If the leftmost was closer to t, then you decrement this pointer by 1. So you had 2 pointers, one on the leftmost of these, other on the rightmost of these. So if the leftmost is closer, then this rightmost will move further to the left. And if this particular rightmost element was closer, then you move the leftmost to the right. Okay. And overall, this procedure will take big O of k time. And so the answer would be log n plus k. So we have some suggestion. Okay, you got it. Okay, so all of you know the answers now. I will also share your metal report, whatever, and whatever, wherever the answer key is wrong, don't worry. You'll get the marks for the right answer. Yeah. But still, I was expecting someone to get full marks in this paper, but somehow that didn't happen. Or at least 35 plus. Yeah, but you can try in the end. See.
Sir, can you explain the question one again, please?
Question 1. So this one?
Yes, sir.
Yeah, so you needed to arrange these functions satisfying in the increasing order of asymptotic group. Okay. So F1 is big O of F2, F2 is big O of F3, and F3 is big O of F4. Okay, so what was the smallest one among these things? So whenever you have these powering things, you arrange them in the fashion 2 raised to something. So what will be this? This will be 2 raised to 3 log n. This will be log n into log n. This is just log n. And this will be linear. Right? And you just need to arrange in order of their exponents. Okay. So option A. So log n comes first. Then comes log n. Then log n into log n. And finally n. Okay. That clear?
Okay, sir. Yes, sir. Thank you.
So will there be relative grading? Yes, there will be relative grading. Obviously, we need to do that. There's no point going absolute because the scores are on the lower side. 30 is the highest, but some of these answer keys might change. So the scores might also get changed. Yeah, we'll see what's the final situation like that. But I think we should keep relative grade. Yeah. Okay, one of you says paper was tricky at some questions and I enjoyed to solve this. So that is good to know. because this is my first time also preparing objective questions in algorithms course. But in NSEM, I think we'll have subjective part also. You will get an idea to describe your, you'll get a chance to describe your ideas. But then you won't have these options. Right? Here it was slightly easier because you had these candidates and yeah, but I think it was not the kind of paper where you could just fluke something and get the answer. Needed to think about it. If we take n equal to 16, it will, yeah, I'm not talking about smaller values here. It's just asymptotic things. So what's the definition of big O? For all n larger than a specific value, this function f1 is a strict upper, sorry, function f2 is a strict upper bound on f. Okay. We never consider smaller values here. Obviously, for smaller values, some of these functions might be inferior, but the notion of asymptotic complexity is that for n larger than this thing, some of this, how these functions dominate each other. Okay, so you all are computer scientists, so should always think in terms of asymptotic. Asymptotic. Okay, there is one more question. Will you post the corrected answer in May? Okay, I can do that. So yeah, try to do better in the end sem. Okay. Hopefully we'll have some stronger scores. Okay, there are no more questions. We'll stop here. Discuss the next topic.